understand the ear. So here is our ear. Say this is the outer part, and it goes inside like that. Now, for the ear, we have got the external the external part where we're going to have different parts, and then we are going to have a tympanic cavity here. So we start from the pinna, what we can see outside. Also going to see the concha, and then we have got the external auditory meatus. So these parts, and of course we'll see concha here, these are just taking us to the inside of the ear. That is going to make up what we call the outer ear or the external ear. And then as we get to go inside, we have got the tympanic membrane there. To the tympanic membrane, we have got a bone attached to it. And this bone attached to the tympanic membrane is known as the malleus. To the malleus, we have got another bone that is attached to it, and that bone is known as the incus. To the incus, we are again going to have another bone attached to it, and this bone is known as the stapes. So these parts, these tympanic membrane, the malleus, incus, and the stapes, we call this as the middle ear. Now we also have two muscles, the stapedius and the tensor tympani, as muscles of the ear. Those are going to just be pulling on the eardrum and also getting stapedius is attached to the stapes. The aim is just to make sure that these guys contract when you are getting a high sound, so that the components of the inner ear are not destroyed by loud music. And then now we are going to have the parts that to make up what we call the inner ear. So for the inner ear, we're going to see these structures. So we have got the semicircular canals, and then we have got this shell-like structure. Okay, so that is our inner ear, and this part is what is actually involved in both hearing and balance. The middle ear, remember, it is this part. So the the stapes, the bone, is attached to the cochlea. This round structure is known as a cochlea, which looks like a snail. That's the cochlea. What's its function? Is involved in hearing. And then we have got what we call the vestibular apparatus. The vestibular apparatus are involved in hearing. But then before we go to the vestibular apparatus, let's talk just a bit, just because we've already talked about hearing, just a review, right? So when we look at this snail-like structure, which is the cochlea, when you make a cross section of the cochlea, you are going to find that inside the cochlea you are going to have cavities. You have got the cavity that is on top and the cavity that is down. The cavity that is on top is known as the scala vestibuli. The one that is down is known as the scala tympani. These two cavities are filled with what is known as perilymph, and we know perilymph is rich in sodium because it's similar to ECF. And then we have got the scala. This is going to be now, okay, we have the vestibular, the tympan, and then the scala. Just look, where is it? On the middle, right? Scala media. Scala media is rich in potassium. So the scala vestibuli and the scala tympani, these guys are going to have a part where they are going to be continuous with each other, right? They are going to be continuous with each other, at one part. And then the scala media, the cavity inside there, has got endolymph, as we have said. The scala media cavity is also going to have another name, right? So now just consider of these three, which one is the actual one involved in hearing. So the scala media is the one that is going to have the organs of hearing, and we call that as the organ of Corti. The organ of Corti is going to contain the inner ear cells, the outer ear cells, the spiral ganglia, and these guys are involved in hearing. Now, like we know, the ear cells, specifically the inner ear cells, are the ones involved in hearing. There is a longest stereocilia, also known as gynoecilia, and then the shorter ones. These guys are attached by tiplings, which contains potassium gated channels. So what is going to be happening is that because these guys are actually inside the scala media, they are found on what we call the basilar membrane. Now, inside the scala media, you are going to have two membranes, the basilar membrane and also another membrane. And the other membrane, we refer to it as the vestibular, also known as the Reisner's membrane. Vestibular, also known as Reisner's membrane. So these two membranes are the membranes that are going to differentiate or separate endolymph found in the scala media from the perilymph found in the two other cavities. Okay, so remember, as I said earlier, that as you get to go along the cochlea, there's going to be a point where the scala vestibuli and the scala tympani communicate, and that place is known as the strema. Okay, there. So the scala tympani, just like you can see here, I mentioned to say the stapes is going to attach on the cochlea, and that part where it is attaching, we have got an opening which we call the oval window. But then the scala tympani is going to open somewhere here, and that opening is known as the round window. Remember, it's the scala tympani. Okay, there. So we should understand also that. So what is going to happen is that because inside the scala media we have got the basilar membrane, and on top of the basilar membrane, that is where you find these air cells, the inner air cells. So when sound hits the tympanic membrane, it starts to vibrate. That spreads the vibration to the medias, to the incus, to the stapes, and then the vibration will enter by the oval window, and it will start now causing the the basilar membrane to also vibrate, to move up and down. The beginning of the basilar membrane is known as a base, and it responds to high frequency. The end of the basilar membrane is known as the apex. It represents to is going to respond to low frequency. All right. So take note of that. And then what is going to happen is that because on top of the basilar membrane you have got the hair cells will start to move, and what happens that the shortest kind of stereocilia moves towards the longest, and when that happens, that opens this potassium gated channels which are found in the tiplings, and potassium flows in. And what is going to happen as potassium flows in, it to at the bottom flow out, and then the calcium is now going to flow in. Calcium flowing in is going to lead to exocytosis of glutamate, which is the major neurotransmitter in the central nervous system, and that is going to go to the postsynaptic neurons or the postsynaptic cells, and that is going to lead to a depolarizing uh, potential in these neurons. And because there are a lot of them, they are going to add up, and then they form a true action potential, and this is being carried. This is going to make up what we call the cochlear division of the vestibulocochlear nerve in what is known as a spiral ganglia, because it looks spirally, and then it's going to now go to the brain, right? It's going to go actually to the central nervous system. So I want us to understand how does it move then. So what is going to happen is now we are going to go into the central nervous system, where we have got the medulla. On top we are going to have the pons, Let me just put this a bit proper. Shouldn't be too big also because we'll not see. Right, so let me start from here. This is the medulla, the pons, the midbrain. Also the other side like that. So what you are going to see is the nerve coming from this spiral part is now going to go in the medulla, specifically the rostro medulla. Okay, rostro aspect of the medulla. And what is going to happen there is that you have got what we call the cochlear nucleus. Now the cochlear nucleus, let me put one here and another one here. It is divided. The cochlear nucleus is divided. We have got the dorsal, let's say the top part is the dorsal cochlear nucleus, and then we have got the ventral cochlear nucleus. But then when you just look at the ventral cochlear nucleus itself, it's further divided into, let's say this is going to be the anterior, all right? So it's going to have the anterior part, and then it's going to have also the dorsal part. So therefore we have got the anterior ventrocochlear nucleus, dorsoventrocochlear nucleus, and the dorsocochlear nucleus. So three in total. So what is going to happen? That is going to also be the same way with this side. I want us to understand what is happening here. Okay. So when the information comes from the cochlea in this bipolar neuron, which is the spiral ganglion, the cochlear branch of the vestibular cochlea. I've changed the way I wrote it. So, like that. So, these nerves are going to project to the dorsal cochlear nucleus, the ventral anterior cochlear nucleus, and the dorsal anterior cochlear nucleus. Then what is going to happen from here is that some fibers then are going to move. Please follow it well, all right? So some fibers are going to project. You can see you have got the fibers that are in the dorsal cochlear nucleus. So going in the pons you are going to have an area that is known as the superior olivary complex. Can I give it as S or C? The superior olivary complex. So what is going to happen is that some fibers are going to project from the dorsal cochlear nucleus, and then they will go to the superior olivary complex on the ipsilateral side. At the same time, some fibers are going to project also, and then they are projecting from the anterior ventral. Please take note of this. You can see the anterior ventral is this one, right? And then they are going to project to what we call not the superior olivary complex. Okay, first before we talk about that, let me just put on some structures here. So be on the junction, because remember this is the medulla, this is going to be the pons, this is going to be the midbrain. On the junction of the pons and the midbrain, you have got what we call the nucleus of the lateral lemniscus. Nucleus of lateral lemniscus. Okay, there. And then another structure that I can put here is just like we have got superior liver complex this side, we also have one this side. And then we are also going to, now we are going to go into the midbrain, right? So in the midbrain, we are going to have what we call the inferior auriculi. So say this is the inferior auriculi. In the midbrain, we also have what we call the tegmentum. I can as well put that. Remember the parts that make up the midbrain? Substantia nigra, tegmentum, tectum. Okay, tegmentum. Now let's follow up the fibers. We see what is happening to them. So some fibers then are projecting from the ventral, okay, the ventral anterior cochlear nucleus, and then look at how they are going to the opposite side. On which part? The superior olivary complex on the opposite side. And then from the superior olivary complex, what is going to happen is that some fibers are going to move direct from here. They will go to the inferior colliculi, okay, like that. And then that is going to be the same way with the opposite side. Some fibers are going to move from here and go to the inferior colliculi. But then these guys will also send some collaterals to the opposite side. Actually, these guys decassette. They also send some collateral to the opposite sides. Okay? Please take note of that. And then what is the other thing that is going to happen? You are going to have also some other fibers that are going to now be projecting from the dorsal ventral cochlear nucleus. Remember the dorsal ventral, it is this one. Look at where they are projecting. They are projecting from here, but these fibers are going to go just straight to the contralateral inferior colliculus. You can see straight to the contralateral side. That is not all. You are also having fibers coming from just also on the opposite side. So first, before I even go further, these fibers that are coming from they are coming from the anterior ventral cochlear nucleus. They are going to make up what we call the ventral acoustic stria, and we call this as the trapezoid body. Okay, and then we have got fibers that are going to move from. You can see we follow them from the dorsal ventral cochlear nucleus to the inferior colliculus. So this makes up what we call the intermediate acoustic stria. You are also going to have some other fibers, and these fibers are going to be moving from the dorsal cochlear nucleus just here, and then they are also moving going up to the inferior colliculus, and these will make up the dorsal acoustic stria. So I've got the ventral acoustic stria, the dorsal acoustic stria, and the intermediate acoustic stria. So that you now just understand how they are moving a bit cleanly, right? So let me put the structures like this. Here is our midbrain. Here is our pon. And then there is the medulla. And then I'll put again the nucleus. Let me write it differently so that maybe it will be way easy. So let's say this is the dorsal cochlear nucleus, and then we have got two guys like this. And then I'll just give them letters. So this is going to be the dorsal cochlear nucleus. This is the dorsal. Let me put the first one as not dorsal but as ventral or anterior. This is going to be the anterior ventral cochlear nucleus. This is going to be the dorsal ventral cochlear nucleus. So what we are saying is that in the midbrain we have got the inferior colliculus. Okay, inferior colliculus. And then also in the pons, we have got the superior olivary complex. I'll put that as superior olivary complex. What is happening is this. Fibers are going to move from, let's start with the dorsal cochlear nucleus. From the dorsal cochlear nucleus, they are going contralateral. Contralateral, you can see to the opposite side. From dorsal to the inferior colliculus, we are forming what we are calling as the dorsal acoustic stria. Hope that is clear, right? And then from the anterior ventrocochlear nucleus, we are simply reaching up to here. Can I put this in another color? we are simply reaching up to here. And this is because it's coming from anterior ventral, it's forming what we call the anterior acoustic stria, which is also known as the trapezoid body. And then now we're having fibers coming from the dorsoventral. These guys, you can see they are passing on the middle. They are still going up to the inferior colliculus. And these guys are making up what we are calling as the intermediate acoustic stria. Hope that is clear now, right? But then from the dorsal cochlear nucleus, some fibers are also moving ipsilateral. You can see they are going ipsilateral up to the superior olivary complex. And then now take note from here. From the superior olivary complex, we are going to have fibers going to the inferior colliculus again. So which color can I even use here? Okay, let's hope this one will appear well. Okay, so from the superior olivary complex, you are going to have fibers projecting to the opposite side. You can see you also have here fibers will still project to the opposite side. But they don't only go to the opposite side, you also have fibers going to the same side and fibers to the same side. Okay, like that. Hope that is also clear. Where are they moving from? Moving from the superior olivary complex to the inferior colliculus, right? And that is going to make up something that we are referring to as. So we have got this pathway. We need to know also its name. That is known as the lateral lemniscus. Okay, lateral lemniscus. But as these fibers are going in what we are calling the lateral lemniscus, between the pons, remember these are the pons, this is the midbrain. There is a nucleus here on the junction, which we are calling as the nucleus of the lateral lemniscus. So they are passing through that. Hope you get it. Okay, they are passing through that. And then now from the inferior colliculus, the fibers are going to go to the thalamus in what we call the medial geniculate nucleus. And then from here now they are going to go to the cerebral cortex. In the cerebral cortex, that's where we find the primary of auditory area. So you need to know that you have got different orders of neurons. You have got the first order neurons. So the first order neurons are located where? They are located in the spiral ganglia. And then where are they terminating? Remember what we already said. So from the spiral ganglia, they're terminating in these nuclei here. The dorsocochlea, the anterior ventral, the dorsoventral, right? And then they are forming different stria, the dorsoacoustic stria, the intermediate acoustic stria, and the ventroacoustic stria. That is the first order neurons. How about the second order neurons? So the second order neurons, these guys are projecting. Look at how they are going to be moving. They are moving from two ends. Can you see that? You can either move from the superior olivary nucleus or the complex, this portion. Going where? Where are they going? They are going to the inferior colliculus. Or you can as well move from here. What is this part? It is the lateral reminiscus nucleus. Okay, so those are the two parts. You have got the lateral lemniscus nucleus and what? And the superior olivary nucleus. So these ones are going to the medial geniculate nucleus. Okay, take note of that. And then where are the fourth order neurons? The fourth order neurons, they are going to pass through the internal capsule and then they are going to the primary auditory area. The primary auditory area is found in the superior temporal gyrus and is actually known as the transverse gyrus of Hissel. Okay, that is that. So just let's do a quick overview. The first order neurons from the spiral ganglion to the cochlear nucleus, making those the three pathways, right? The dorsal, acoustic striate, the intermediate, and the ventral. The second order neurons are coming from they are going to be going to the lateral meniscus nucleus, right? That's where they are going. Second order neurons. Second order neurons are going to the lateral lemniscus nucleus. You can see here. Actually, the first one is going to the superior olivary complex here. And then from the superior olivary complex on the controller on the ipsilateral side, some fibers are going to the lateral lemniscus nucleus. Those are second order neurons. That's where they are going. Remember, they are coming from where? They are coming from the dorsocochlear nucleus. Okay? And then the third order neurons, where are they coming from? They are now coming from the same parts. So now coming from the lateral lemniscus nucleus and the superior olivary complex. Where are they going to be going? These guys are going to be going to the medial geniculate nucleus. Okay, that's where they are going. And then the fourth order neurons are the ones that are reaching to the cerebral cortex. So that is it with the overview on the auditory system. Now we'll talk about the vestibular system.